सो हेलो स्टूडेंट्स, स्वागत है हम आपका हमारे यूट्यूब चैनल पे। तो आज एक नए चैप्टर की स्टार्ट करने जा रहे हैं, जिसका कि हमारा हेडिंग्स है, वो है हमारा बाइनोमियल थ्योरम। सो आज देखते हैं इस क्लास में क्या है बाइनोमियल थ्योरम, कहाँ इसका यूज हो सकते हैं और इस पे किस टाइप के क्वेश्चंस आईआईटी में आस्क किए जा सकते हैं। तो लेट मी शेयर माय स्क्रीन। So I think my screen is visuals to all. अगर सभी को मेरी स्क्रीन दिखाई दे रही है तो प्लीज लाइक द वीडियो। चलिए तो स्टार्ट करते हैं बाइनोमियल थ्योरम के बारे में। बाइनोमियल थ्योरम, as we know that the binomial in the polynomials chapters we have been studied about the what is the polynomials, what is the monomials, binomials, trinomials. So generally the monomials, mono means one. Mono means one. If the expressions will have the only one value, only one term, that is called monomials, such as any variables like x, 5, any constant value. It is the monomial functions. Binomials means in any expressions there will be the two term. Bi means two. So it is called binomial, such as x plus y, z plus 9. These are the uh, binomial expressions. And polynomials, which the terms having the more than the two terms, that is called polynomials. So here in this chapters we will study about only the binomial, means which has the only two terms and to the power of raised to the power of any numbers we can find its expansions. This is very useful for solving the questions. So many times these theorems can be used in the different types of the problems, like in other chapters like arithmetic progressions, in the trigonometric series it can be asked. Okay, so first of all we will see what is the binomial. So first of all we will see its definitions. So its definitions, it is the formula, it is the formula for which for which not for which, by which any power of a binomial of a binomial can be expanded in a series, that is called the binomial theorem. Binomial theorem. Okay, so if we see the binomial theorem, that is the a plus b whole square. We know the expansions of the a plus b whole square, that every students has been studied in the class 6 7. So everyone remember that is the formula for a plus b whole square, that is a square plus twice ab plus b square. In this formula, our Prime Minister Modi has been confused about this formula a plus b whole square. A square plus twice of ab plus b square. So twice of ab will be added in this term. Means if we do the whole square of something, we will get the extra something from the formula. Okay. So even the Prime Minister Modi does not know about this formula. So here you will know. Okay. So now we will see the a plus b whole cube. It will be the a cube plus 3a square b plus 3ab square and plus b cube. Okay. Now, can you tell me the formula of a plus b whole to the power 4? Its formula will be a to the power 4 plus what? 4 a cube b plus 6 a square b square plus 4a b cube plus b to the power 4. Okay, similarly, we can find the formula of the a plus b whole to the power 5, a plus b whole to the power 6 by using the binomial theorem. How we can expand this formula? So there is only one formula for the binomial theorem, that is the x plus a whole to the power n. So this formula will be written as, there will be the combinations concept will be used, that is the nc0 x to the power n and a to the power 0. Now plus nc1 x to the power n minus 1 into a to the power 1 plus nc2 into x to the power n minus 2 into a square. Now nc3 into x to the power n minus 3 into a square, up to, it will go up to n terms because the exponent is n. So ncn x to the power 0 and a to the power n. You can see the first exponent. The first exponent of the first term will be the similar to this one term, that is the n, and this one suffix of the combinations will be used for the the exponent of the second term. Here it is the 0, so a to the power 0. Here it is 1, so a to the power 1. Here it is 2, so a to the power 2. Here it is 3, so here it is a to the power 3. Here it is a to the power 3. Here it is n, so here it will be written as n. So this is the main formula, nc. Okay, so here we will discuss about something related to the combinations. We should know about the factorial notation. Before coming to in the permutations and combinations, we will study about the factorial notations. We know that the 0 factorial is 1, 1 factorial it is 1, 2 factorial it is 2, and because this is 2 into 1, it is equal to 2. 3 factorial it is 3 into 2 into 1, means it is the multiple of the terms which starts from the n, and it will be in the decreasing order. It decreases by the 1. So this one will be the 6. Now 4 factorial, it will be the 4 into 3 into twice into 1. It will be 24. So 5 factorial, it will be the 5 into 4 factorial. We can write because it will comes like 5 into 4 into 3 into 2 into 1. So this one will be 24 into 5, it will be 120. Now 6 factorial, it will be, we can write 6 into 5 factorial. So it will be 720. 7 factorial. You should remember about up to 10 factorials. Okay. So this can be written as 7 into 6 factorial. So it can be multiplied by 7. So this one will be 4 and 5040. Okay. And we will study about here about the NCR. There will be the formula for NPR and NCR. That is the formula for n factorial upon n minus r factorial. This is the permutations. Permutations will be used for the arrangement of the n objects. Okay, and NCR will be used for the combinations of the n objects out of r objects. Means if we have to make the selection, if we have to select the something, means there we can use the concept of the combinations, and where we have to arrange the things, so there we will use the concept of NPR. So here NCR formula will be the n factorial upon r factorial and n minus r factorial. And here we will know about something about NC0. NC0 will be equal to NCN, and its value will be 1. Okay. Now if I say NC1, its value will be equal to the NC n minus 1. Okay, or we can say that NCR, its value will be NC n minus r. Okay, now we will see the expansions of the x plus a whole to the power n. X plus a whole to the power n. We have seen it is NC0. NC0 it is, just now we have seen NC0. NC0 it is 1 and x to the power n, and a to the power 0 will be 1. So its value will be x to the power n plus NC1. NC1 it is actually n into x to the power n minus 1 into a, plus NC2 x to the power n minus 2 into a square, and it will go up to NCN 1 and x to the power 0 it will be 1. So the last term will be a to the power n. Similarly, we can write in this term of the, because this is the summations of the NC, starts from the NC0 to NCN. So we can write the terms in this terms of the summations, and it can be written as from r to 0 to n, and it can be NCR x to the power n minus r into a to the power r, because this is the term from the r to is equal to 1 to n. It will be very summations denotes the summations of the terms. Sigma represents this summations of the terms. It will be varies from r. If you put the value of r is equal to 0, so NC0 x to the power n and a to the power 0. The next term will be the NC1, NC2, NC3 up to NCn. So in the general term, we can write in the summations of in this way. Okay. Now, if you have to find the x minus a to the power n, x minus a whole to the power n, it can be written as, because wherever the a term will become, and a term will be with the powers if it is negative, odd power, so its value will be negative. If the powers will be the odd, in that case it will be negative, and if the powers will be even, in that case it will be the positive. So we can write sigma r is equal to n and minus 1 to the power n and NCR into x to the power n minus r into a to the power. In the summations form, we can write in this way. Okay, if it is given x plus 1 whole square, x plus 1 whole to the power n, so this one can be written as NC0 x to the power n plus NCN, NC1 x to the power n minus 1, and since 1 to the power anything will be the 1 itself only, NC2 x to the power n minus 2 and NC3 into x to the power n minus 3 up to, it will go up to NCN, that is 1, and x to the power 0, it will be the x to the power 0 will be the 1. So the last term will be the 1. So this one can be written in the summations form, r is equal to 0 to n, and it will be NCR into x to the power n, and since 1 is the n minus r. Okay. So here we will see some examples. If I see in the pyramid form, the number, here we will see some properties first. Properties of the binomial term. Properties of binomial theorem. Okay. Okay, so properties of the binomial theorem here, the expansions in the series, expansions of the binomial theorem, there are n plus 1 term. There are n plus 1 terms in the expansion, Okay, the second will be the sum of the sum of index or power, index of both the term is equal to n, is equal to n. Okay, and third one, the TR, the general term of a binomial expansion of binomial expansion of x plus a whole to the power n. It can be written as tr plus 1. It will be equal to ncr into x to the power n minus r into a to the power r. This is the general term of the x plus a whole to the power n. Okay. The fourth one, if n is even term, so total number of terms in expansion, it will be n plus 1. So n plus 1 will be the odd numbers. So what is the middle term? The middle term will be if the power is 2, a plus b whole to the power 2, it's having the 3 terms, 1 2 3 terms. So the middle term will be the n by 2 plus 1, n by 2, 2 by 2 plus 1. That is the second term. Okay, so the middle term will be the n by 2 plus 1th term. Plus 1th term is the middle term. Okay, now if in the properties number 5, if n is equal to odd, so the total number of terms in expansions will be n plus 1. So n plus 1, it will become total number of the terms will be even. So if there will be the even terms means a plus b whole to the power 3. So we can see here it is the 4 terms. So the second and third term will be the middle term. There will be the 2 middle terms. So there will be the 2 middle term. So which term will be the middle term? Middle term is 3 plus 1 by 4. 3 plus 1 by 4 means n plus 1 by 2 second term and n plus 3 by second term will be the middle term. Okay, so here we will see the expansions of a plus b whole to the power 2. So in that case, it will make the pyramid sections. How it can make the pyramid section? That is, the first one will be the 1. Okay, in that case, it will form the 1 to 1. In the third case, it will form the 1 3 3 1. A plus b whole square. Okay, this is the form of a plus b whole square, because we know that a square plus twice ab plus b square. So here the coefficient of the terms of the square and twice ab, that is and this is the term of the coefficient a plus b whole cube. It will be a cube plus 3a square b plus 3ab square plus b cube. Okay, now in the fourth term, it will make the 1 4 6 4 and 1. Now in the fifth case, it will make the 1 5c2. It will make the 5 factorial by 2 factorial and 3 factorial. So 5 into 4 by 2. So it will make the 10 and 5c3. It will make the 5c3. It will be 5c2 and 5c0. It will make 10 here. Okay, and it will be 5c1. 5c1 will be the 5 only. This one will be the 5, 10, and this one will be also 10, then 5, then 1. A plus b whole to the power 5. In the sixth term, it will be 1. It will make 6. After that, 6c 2. 6c2 will become 6 into 6 factorial into 5 into 4 into 4 factorial. 2 into 6 minus 4, 4 factorial. So 4 will be get cancelled and it will make 15. 15, then 6c2 and 6c3. 6c3 it will make 6 into 5 into 4 by 3 into 3 factorial will get cancelled. So this one will be 2. 20, 20 and 40. It will make 40, then 15, then 6 and then 1. So it will make the pyramid shape. We can find the value for the a plus b whole to the power 7, a plus b whole to the power 8 also. Okay. So here we will see the some questions such as it is written find the first four terms in the expansion of 3x plus 1 by x whole to the power 4. So here we have to find the first four expansions. So this one expansions will be 3x plus 1 by x whole to the power 4. It can be expanded like using the formula of a plus b whole to the power n, that is the 4c0 into 3x to the power 4 minus 0, 4 and 1 by x whole to the power 0. The second term will be the 4c1 3x to the power 4 minus 1, that is the 3 and 1 by x to the power 1. Okay. Now the third term will be the 4c2 3x to the power 2 and 1 by x to the power 2. Okay, and the last term will be the 4, not last, we have to find only first four terms. So 4c3 3x to the power 3 into x 1 by x to the power 1. Okay, so 4c0 it will be 1 and 1 by x to the power 0 it will be 1, so it can be 3 to the power 4, it is 81 x to the power 4 plus 4c1 it is 4 into this is 3x cube, it is the 27x cube into 1 by x plus 4c2 its value will be 4c2, it will be 4 factorial by 2 factorial 2 factorial. So 4 into 3 and 2 to cancel, so it will be 2, so it will be 4c2, it will be 6 9x square into 1 by x square, and the fourth term will be 4c3, it will be the 4 only, 3x to the power 1, this one will be 4 3 2 and 1, this one will be 1 and this one will be 3. Okay, so 3x into 1 by x cube. So what are the term? This one will become 81x4 plus x, this one will get cancelled, 27 into 4 it will be 108 x square plus x square get cancelled, so plus 54 and x cube 12 divided by x square. These are the first four terms of this expansions. Okay, now we will see the next questions based on find the coefficient of x to the power 7 in the expansion of x to the power 7 in the expansion of 4x minus 1 by 2 root x whole to the power 13. So we have to find what is the coefficient of x to the power 7. So x to the power 7, first we have to find that the terms. So we know the general term of the expansions. General term in the binomial theorem, it is TR plus 1. TR plus 1, it will be the NC R into x to the power, general term of binomial expansion of x plus a whole to the power n. Okay, so x to the power n minus r into a to the power r. So here we will try to get the tr plus 1 for this binomial expansion. So that is the n is the power, that is the 13 cr into the first term will be 4x to the power 13 minus r into the second term, it is the minus 1 by 2 root x whole to the power r. Okay, so we will try to get the in the terms of the exponent of the x. So we are independent, we will not solve for the 13 cr, only we need the finding the x to the power x. What is the x to the power, how much is the coefficient? So it will be 4 to the power 13 minus r into x to the power 13 minus r, and minus 1 to the power r into 1 upon 2 whole to the power r, also 1 by root x, 1 by root x, it will be also whole to the power r. So only we will see about the x to the power r coefficient. So remaining terms I am writing as it is, minus 1 to the power r and 1 by 2 whole to the power r. Here we can see it is the x to the power 13 minus r, and here it is the 1 by root x. So it is the x to the power minus half. Minus half means minus r by 2. So this coefficient will be added. So x to the power minus 13 minus r upon 3. R upon 3. So make it equal to the x to the power 7. X to the power 7, x to the power 13 minus r upon 3. So we will equate the terms. That is the 7 is equal to 13 minus r upon 3. So what is the r term? So 13 r minus r plus 3, it will be the 4r by divided by 3 is equal to 13 minus 7, it is 6. So r will be equal to 18 by 4. It is r minus 2. It is, so that we should write correctly. It is not 3, it is 2. Okay. R 13 minus r divided by 2. So minus r divided by 2. 7 is equal to 13 minus r divided by 2. So minus 2r and 3r. This one will be 3r divided by 2 is equal to 6. So r will be equal to 12 by 3, it will be 4. And 13 minus 6. So we will find the TR term, TR plus 1. So TR plus 1, that is the T5 terms. It has the coefficient of the x to the power 7. So 11C, that is the 13. What are the? So that will be the T5. So 13C 5 into x to the power n minus r. So x is what? 4x. X is 4x. 4x whole to the power 13 minus 5. It will be the 13 minus 5. It will be the 8 and 1 by 2 root x. 2 root x whole to the power 5. So from here we can find the 13C5 it will be 13c5 into 4 to the power 8 into 1 by 2 whole to the power 5. That will be the its coefficient. Okay. So in the today's class, we have studied about the binomial expansions and its properties. Okay. So for today, it is up to here only. So we are ending the class now. So in the today class, we have seen about the expansions of the binomial theorem and and we have also seen the properties of the binomial theorem based on, and also we have seen some basic types of the questions. Okay, so this chapter is very important. So in the next sessions, we will see about the some extra things about the बाइनोमियल थ्योरम. सो आज की क्लास बस यहीं तक रखने देते हैं, मिलते हैं अगली क्लास को. तो तब तक के लिए शुभ रात्रि, शुभ. So everyone's to good night. We will meet you tomorrow. So ending the session now. So goodbye, good night.